Today's topic is oxygen management during wine production and bottling. And our presenter is Mr. Todd Steiner, Enology Program Manager and Outreach Specialist with the Department of Horticulture and Crop Science, Ohio State University. Todd has been with the Ohio State University for 33 years and has been the leader of the Enology program since 2001. He serves as the state enologist to the Ohio commercial wine industry. His extension responsibilities include co-organizing the annual Ohio Grape and Wine Conference, the annual Ohio Wine Competition, organizing workshops, and being featured presenter at both in-state and out-of-state meetings. He is also responsible for initializing a wine analysis program in working with quality control and troubleshooting for the Ohio commercial wine industry. He has previously served several terms on the board of directors for the American Society of Enology and Viticulture Eastern Section. And one more thing before I pass the baton to Mr. Steiner, I would like you to please, at the end of this webinar, please take 1 minute of your time to fill out the survey that will pop up on the final screen. It's very important for me and allows me to continue this program. So please, 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 and thank you. Fill out the survey that will pop up. And with this, I'm passing the baton to Mr. Todd Steiner.
Andrea approached me about this, which is fantastic at Texas A&M here. It's just amazing, virtually what we can do these days. And some information I had presented on in wineries, probably through some trade show or some other publications, and I do feel that it's extreme to really pay attention to oxygen management in the winery, and ultimately, especially at bottling. I think that is a critical time, and we're going to cover a little bit in the cellar as far as management, but mostly at bottling, because if we want a quality product in the bottle with and wine stabilization, I think we really need to be paying attention to oxygen management. So with that said, certainly, again, I'd like to thank for their webinar series. Fantastic way to get great info on wine production and best management practices. And Dr. Andrea Bottizzato for all her excellent work as the extension specialist there at Texas A&M and the organizer here of this webinar. And then also to all the attendees that are on board. I know, it's a critical time of the year. We're getting out into the ready and going and trying to bottle wines and things like that to have tanks ready for the upcoming harvest. So willingness and interest to increase your knowledge in winemaking procedures and practices, and especially on the area of oxygen management. So we'll look at just a brief outline, kind of some beneficial aspects of oxygen and mostly problems. We tend to think of oxygen being mainly detrimental to wine quality, and that's really true. However, there are essential times where oxygen is really critical to the management and of quality wine production. In light of some of the things I'll present, we developed an action plan at the Ohio State University within our Enology program to take a look at this important aspect, because I think all too often in the eastern section and in the Midwest, and even some parts of the West, I'm sure we're just not looking at this topic enough. So a bottling line kind of audit or study that we're going to cover and put it more on a practical basis that we can all learn something from, maybe based on our own situation, our own. And then we'll cover some of the effects of sulfur dioxide use and oxygen interaction, as well as some, throughout the course of the talk, some recommended actions also. Looking at oxygen uptake itself, there, some of the benefits of that we see in oxygen, several areas, and one is hyperoxidation. I don't know how many that are with us today practice hyperoxidation, but it's a procedure where it's intent to the must or juice of mainly white varieties. And really the whole idea there is to prevent further post-fermentation browning reactions from these phenolic precursors. So, and that's important. One school of thought is that, down the road, it's going to help prevent oxidation from these sources and hopefully extend shelf life. Now, we'll see some mixed reviews and literature on this. We've done some trials and worked with a graduate student at Ohio State on this. And with all that's involved, we didn't necessarily see positive benefits to recommend that practice. We can go on the other flip side, where when I was in Italy for a little bit, this probably was at least 10 years ago, maybe more, extreme, looking at hypo oxidation, which they're really at their harvest procedures, they're pressing, crushing, they're trying to prevent oxygen to a great extent with an inert gas kind of in a closed system. Now, I don't know that we regular pressing, crushing and pressing techniques, as long as oxygen to minimum standards as far as absorption, I think we can come up with a pretty good product in bottle. The other time that we really need oxygen is through alcoholic fermentation. So, it's really essential for our yeast in the growth phase to create that proper biomass that we're looking for, and to make sure our fermentation, in a good way to completion. So we're not picking up these nice aromatics, fruit forward profiles that we're looking for, and make sure we get to completion. So, we can provide some oxygen through the mid part of fermentation if needed, depending if it's a little sluggish, to help out there. However, we get towards the latter part, I tend to not recommend a lot of oxygen at that point, unless it's a situation we have excess or stuck fermentation, and maybe we need a little oxygen along with maybe some nutrient to help kind of kickstart our yeast to get our yeast going again and hopefully finish fermentation, or possibly look at performing a stuck fermentation protocol at that time. The last thing I'll just, the benefits of oxygen would come through, say, micro-oxygenation, where it's a specific procedure identified, or specific equipment or dosage units that we can dose, and the term here is micro. So we really don't want excessive DO levels in the wine, and that's not the intent. But it's really for those red wines that are maybe a little bit harsh or bitter, astringent, or amount of
Todd, I can't hear you anymore.
Can you hear me now, Andrea?
Yes, and Agustin is asking if you could pause from time to time, please, for him to.
Okay.
Thank you.
Okay, thanks for reporting that. So So yeah, with micro-oxygenation, make sure that we monitor that. It's a specific procedure that we can. It's also good for polymer, the bitterness that we may find in our wine. So it can be a procedure where the use of oxygen is beneficial for us in the wine. But more than not, generally oxygen is detrimental for wine quality, fermentation, through cellaring, bottling, and aging of wine. And we basically two different sources. One, enzymatic and or non-enzymatic. So enzymatic, we see that through polyphenol oxidase or PPO, and also lactase. So as soon as we crush the fruit or the grapes, we see the polyphenol oxidase enzymes at work, and those create the browning reactions that we may be associated with, and the phenols or the polyphenols, as well as lactase, which is from unsound or compromised fruit, and mainly fruit of botrytis, infected fruit. The lactase is much more difficult to handle. It doesn't have as much of effect from sulfur dioxide. Polyphenol oxidase, we can handle polyphenol oxidase a little bit more with as soon as we put sulfur dioxide, then we can essentially stop that from occurring there. So the other form of oxygen or oxidation we see is through chemical or non-enzymatic. And this is really a reaction of wine components, mainly polyphenols, with oxygen, that form these brown colors that we're associated with when we look at oxidation, and also the resulting compounds of hydrogen peroxidase that can and convert it to acetaldehyde, and we create that nutty sherry-like aroma that we're familiar with upon sensory evaluation of oxidation. The other issue we see with problems of oxygen pickup through microbial issues, and that is mainly through just some examples that are aerobic microbes that are aerobic in nature. So acetic acid bacteria, which are renowned for creating acetic acid and or vinegar, and then film yeast, which is very problematic, especially if we notice compromised fruit coming into the cellar. That may be something that we would want to flag that tank and say, we're going to watch that through the harvest procedure, because wild inoculum or wild, it could be a problem in cellar aging. And some of that could come through film yeast or so they're definitely a problem at that time. They have value. I think the blending ratio has been on, so it's difficult to blend that out, which has an acetaldehyde byproduct as well. But so we need to just be cognizant of temperature control for this, low temperatures, Headspace, good SO2 management, and that should help us out. Disease is another one of concern that's aerobic. So that one we're typically used to that through barrel aging of reds. So that, again, we would want to keep make sure our SO2s, and that way we can help prevent that from occurring as well. But that gives us our typical barnyard types of air associated with through Brettanomyces infection. And, that can be problematic because it can cover up our varietal character as well as qualities that we want to come out of our wine. So in the early stages of problems with oxygen pickup, we may just see a drop of varietal character. We may wine coming through fermentation, and maybe after cold stabilization, where we're getting into cellaring of the wine. And then we notice maybe just a simple or flavor attributes. And we can notice this especially in aromatic whites, but we can also notice it in reds as well. And it could be just a reduction or a muted fruit. And typically when there's a reaction taking place in the wine, such as oxidation, the beginning just might be a reduction of fruit. So something to be cognizant and take some proactive measures. It could come through maybe some light bruised apple instead of that intense sherry or nutty character that we might be familiar with forms of oxidation. And we may notice this prior to any browning that might occur in white wine in our red brick hues that might form in our red wines. And then, throughout cellar aging up through bottling, that absorbing into the wine, certainly a concern just for, shortening shelf life, instability in a bottle. And these are really come to light when we see low SO2. And we'll talk about this here in a little bit. Any vessel headspace, whether it's barrel, tank, HDPE, the high density polyethylene containers, anything like that with temperature and time, obviously. Okay, so how can we limit oxygen exposure? So oxygen can range in wine anywhere from 6 to 9 milligrams per liter or parts per million. Obviously, we want our values lower than that. However, 6 to 9 is really kind of approaching the saturation levels that we see of oxygen. Interesting things, it dissolves more rapidly at lower temperatures. However, the process of oxidation occurs at a greater rate at warmer temperatures, just like many chemical reactions or reactions we see in wine. They tend to happen quicker at warmer temperatures. That's why cold stabilization becomes a concern. So we're going into cold stabilization at 27 or 28 degrees Fahrenheit. So there's a lot of room for excess entrainment of oxygen into that wine. And then when we bring it out of cold stabilization and the wine warms up, then that will happen at a greater rate and take place fairly quickly with all that oxygen that absorbed in the wine due to that low temperature. So that's something to be cognizant of. We need to make sure for cold stabilization, for those that are practicing that they have their SO2 levels where they need to be based on pH and molecular form of SO2, and no headspaces in that tank during that cold stabilization process. We want to avoid potential sources for oxygen pickup anytime we move the wine. These are offering excessive or times where we might have excessive buildup of oxygen. So anytime we rack the wine, pump, filtration, whether it's after blending or fining if needed, there's a chance that we're going to absorb more oxygen than we would desire. So considering this, we'd want to keep tanks full, secure any loose connections that might be associated with a pump or filter, make sure pads are tight in the filter. And then one of the most important things that we can take home here, and we're going to see this on the bottling information, is use an appropriate inert gas to purge the transfer lines and the receiving vessel that we're going to rack the wine over to. How much oxygen is in that transfer line as well as the receiving vessel? We're really absorbing a lot of oxygen into that wine just through that process. Some other things we can do to limit oxygen exposure is, pending variety and wine style. We can provide extended lees contact where lees provides kind of an oxygen as an oxygen scavenger. And it can also add some potential mouthfeel effects. So certainly for something like Chardonnay or Pinot Gris, maybe Viognier, those types of varieties, and of course reds, that can be beneficial and can also add an antioxidant ability or capability to our wine, where if we have the desire to utilize a little bit lower amounts of sulfur dioxide through lees contact, we can achieve that to some extent. We can do some light stirring with something known as batonnage that many are familiar with. However, I would recommend that we just avoid excessive stirring, which can cause more dissolved oxygen into the wine than we want, and have more detrimental effects than positive effects from any lees aging there. So, if we choose to do it twice a month on stirring, at least we're getting those yeast kind of brought up into the wine where they can autolysize and release some of the manoproteins and help aid also in the mouthfeel effects that we're accustomed to with this procedure. We can also add some enological tannins during the course of cellar aging that can react with available oxygen and help reduce oxygen levels at that point as well. So these are all just kind of things that we can monitor, things that we can be a little proactive to help lower our oxygen going into bottling, which we're going to talk about more. However, I do have this last statement in red just because I think it's one of the most important things that we can monitor and maintain in wine quality, and that's sulfur dioxide levels. And that would be the proper use of sulfur dioxide. So certainly not, but to a greater extent, not making sure that we don't have too little. And so, after primary fermentation and malolactic has occurred, I think it's really important to be at this 0.8 parts per million free SO2 level for whites, and 0.5 to 0.6 ppm for reds, based on pH. And a lot of times we think of that mainly at bottling, but it should be that, in my opinion, through the cellaring process. So we protect from microbial issues as well as chemical oxidation.
Hey, Todd, just
yes.
a reminder, if you could take short breaks at the end of each phrase, that would be very helpful. Just
okay. Okay, we'll do that. Thanks, Andrea. If the oxygen content is too high going into bottling, we'll cover this here more in detail, but we can sparge the wine with an inert gas like nitrogen or carbon dioxide to lower that dissolved oxygen content. Use nitrogen because if we add too much carbon dioxide prior to bottling, then we have a chance of getting more of a tactile sensation that's unwanted, especially to our red wines, that we'll notice more on the palate sensorially. White wines, we can take a little bit of CO2 to provide some freshness. However, we don't want excessive, and also excessive amounts may cause the cork to push out after bottling, and that can be definitely problematic. The recommended levels of dissolved oxygen in wine, we typically see somewhere around kind of a target level to be below 1 milligram per liter or parts per million. We can kind of break that out and say, well, reds can take a little bit more, maybe somewhere because of the phenolic and tannin compounds in them. 0.75 to 1 can be ideal, whereas whites and rosés, we would tend to say, we want to be real cautious on how much oxygen we're absorbing into the wine. So we would like to see somewhere about 0.5 to 0.75 there. So in light of the importance of oxygen management that we've shown and some of the detrimental effects, we felt that through Ohio State, it was essential to kind of look at this further, and we wanted to send a kind of a paper survey to our industry and just see what kind of some potential problems could be, and what our oxygen awareness is kind of in the cellar as an industry, and particularly at bottling. So through that initial assessment, we determined oxygen levels with wineries. We determined that was a problem or a potential problem. So we had wineries send us some wines, white, red, and rosés shortly after bottling. And we wanted to say, okay, where are we? Is this of concern for further evaluation? And, we did see higher DO levels or levels of concern that came out of this. The only thing is that it didn't account for Headspace oxygen, oxygen in Headspace, or total package oxygen, which are pretty important to evaluate. So out of that, we kind of developed a bottling line audit process on a way to attack this. And we worked with several participating wineries. And through that work, we said, this is worth further investigation. So we're going to develop a larger study. And we looked at 14 wineries in Ohio. And we wanted to look at the effect of temperature on DO, dissolved oxygen at bottling, as well as DO at the holding tank, the pump outlet, the filter outlet, the filled wine itself, the bottle headspace, and the TPO, or the total package oxygen. And then we also wanted to look at the effect of DO and headspace oxygen on SO2 over time, which is critical, for shelf life stability, and really the quality assessment of that wine. So we were fortunate enough to have purchase a NomoSense trace unit where it can quantitatively measure dissolved oxygen during really all stages of the winemaking process. But it works off of oxoluminescence technology, where the oxygen down here can come in contact with the probe, which is a kind of a sensor foil, and they have optical fibers. And through this this optical transmission, it can go up to the unit, and we can read the oxygen reading in as dissolved oxygen or as oxygen in a headspace. So this is just unique because we can do it non-invasively through the bottling process, where we don't have to open the cork and create some variability with oxygen running in there and affecting our readings. So we just have a sensor dot. I'm not sure if you can see my cursor, but sensor dot in the headspace, and then also one down here in the wine for the dissolved oxygen. And then we can take those readings and figure out, okay, how much are we picking up through the bottling process, which is important. So with that, again, our study consists of 14 wineries. So for Ohio, really this is how we developed our criteria. We determined small wineries, anything less than 10,000 gallons. And then medium were between 10,000 and 50,000, and large were between 50,000 and 120,000. So that's typically what we would see in our industry in Ohio, with a greater number of wineries towards the medium and small category, but we do have some even above the large there that we listed there. We divided them up into different regions of the state. So looking at the pre-preparation of our bottling runs, it took some pre-preparation. We had to receive the bottles from the wineries that they were going to bottle ahead of time, so that we could determine the correct headspace. So we had to have their closure to determine their closure length as well. So we knew where to put the sensor dot into the headspace area, and then also into the DO. And then we took those bottles or those cases with us to the winery prior to the bottling line audit. And then we also placed a sensor dot in sight glasses, and that we could connect in line after the pump or pad filter. And I say, if applicable, if a winery was using a pad filter to filter the wine prior to going into any pre or sterile filtration, membrane sterile filtration. So we could measure the oxygen content after the pump and the pad filter to see how much we're picking up there. This is just a picture of the wine actually once we pulled it off the bottling line. But you can see, before it had wine in it, we had to determine where the headspace level was based on their previous runs with these black marks. And then, here we're lucky enough to calculate correctly and have the sensor dot at the right spot for the headspace during that run. And then you can see the sensor dot in here that's going to monitor analyze the DO for that wine. So once we're at the winery, we wanted to take the temperature of the wine at the bottling tank, because that's critical, and we'll cover that in a little bit, and also the initial DO. And once the bottling run started, then we would take the readings at the sight glasses after the pump and the filter. When we normally do a regular audit, really the bottling line size would determine the number of bottles that we would want to run for our audit. So it really is kind of based on the number of filler heads or filler spouts that are present in the line. And the unique thing about this is in one instance, or several maybe, we actually found where one filler spout was actually the valve, or the rubber valve there, was not sealing proper. It was cracked. And we were scrubbing more oxygen into the system than any of the other filler valves. So it's kind of unique that we could do that. So we run reps through the beginning, middle, and the end of the bottling run. And then taking a temperature and DO at the bottling tank. The bottling room in this case was on the other side. So we're just taking initial temperature and DO, and here is after the pump. You can see in the sight glass, you can see the sensor dot there to evaluate DO after that. And then DO after the pad filter. In this case, it was a white wine. And we can note that this wine was actually too cold prior to filling. So we can see some of the effects of temperature on increased DO at bottling here. So we collected 12 bottles. We're in triplicate through the middle of the bottling run. And really we chose the middle because that's probably where the run is going to be the lowest in DO. As opposed to the first third of the, it kind of works as a bell or a U shape. The first part of the third of the bottling run tends to be a little higher in DO, whereas the middle of the bottling run tends to be lower, and then back up. If we think about the bottling tank, as we get lower in volume, we tend to pick up increased amounts of DO. So the last third of the bottling run, we tend to be higher. So we chose the middle because if a winery is going to have trouble with dissolved oxygen, we'll definitely see it in the middle as well. So then we wanted to have enough triplicates to cover these analytical times post-bottling to see the interaction on these parameters tested. So we pulled the bottles off after corking to look at DO and Headspace. And then we put them in a spreadsheet to get our TPO, or total package oxygen. Here we're just looking at the measuring the DO in the wine once we pulled it off the line. And then we would also look at Headspace too. These are just the wineries, 14 wineries that were in the study. Since we're a little short on time, I'm just going to cover this pretty quickly. Again, winery size, small, medium, or large. Filler type, whether it was a automated filling, gravity, which we have a number of gravity operations, filling operations in Ohio. And then looking at the closure, if it was within the automated bottling line, or if it was a semi-auto or monoblock type of a corking machine, or if they were doing it manual. Then did they provide bottle evacuation prior to filling, whether that was through an inert gas or vacuum. And then also if there was any Headspace treatment we looked at. Again, was it vacuum or an inert gas? And we also looked at closure type a little bit. So some of the results of the study, we saw that wine temperature was an essential factor at bottling. So the correct wine temperature, I would say is roughly between 68 and 70 to be, kind of specific. This will help provide less DO, a little more control on thermal expansion, as well as control, the Headspace levels or the fill levels. When we looked at temperature, 6 wines out of the 14 were actually within this correct value. And the temperature range was quite a range, anywhere from 54 to 74. So, way too cold on the lower end, and really higher than what we would like on the upper end too. But we saw one particular instance with temperature control. This was another bottling line audit that we had where they rushed the wine. after cold stabilization, bottled much too cold. So that's really leading to more than a threefold pickup in oxygen. And this also ultimately causes a large depletion in free SO2. So really, really of concern there. This just shows through an article that Dr. Galander, a predecessor of mine I trained under, wrote an article and had some information presented on the effect of temperature and oxygen absorption, just with simple tank pumping. At 70 degrees versus 50, we see almost a threefold pickup in oxygen entrainment into the wine, which is of concern. And splash racking, we can see upwards towards 7 milligrams per liter or ppm, which is getting closer to saturation levels. So not something I would necessarily recommend there. Let's look at the holding tank DO levels. So, our suggested guidelines are really coming into the holding tank or the bottling tank, if you want to call it, below 0.5 ppm DO, at or below. If it's higher than that, we can have problems with higher levels coming through to the bottled product. And if it is higher, then we can say it might be worth further investigation to our practices and procedures that we're doing during the winemaking process and try to lower oxygen at that point because we don't want chemical or microbial instability in the bottle due to high DO. So we observed quite a bit of range in this study, anywhere from 0.2 at the holding tank DO to 3, which is well above the limit we'd like to see. 5 wines were below 0.5 ppm, which is good. However, 9 were above the recommended limit. 6 of these 9 wines were what we would call in a medium range. So they were 0.5 to 1.5 parts per million, which with proper SO2 management, I think these potentially can be handled. However, 4 of those wines were at too high a levels. And, we were somewhere about 1.5 to 3 ppm on DO at the holding tank. And if we have high DO levels at the holding tank, we're going to get high DO levels, even higher through bottled wine. And this just expresses that, this graph. We can see kind of what we determined coming in at the holding tank, low DO levels. So at 0.5 or below, kind of our mid-range here category in the middle. And these were 0.5 to 1.5, and then greater than 1.5 at the holding tank. So we see in each case, through the bottling process, we increased our oxygen DO content, which is expected, but also of concern. Now looking at DO in the bottled wine, I've already mentioned this U-shaped curve and how oxygen or DO is affected throughout the bottling process. So I won't cover that just to save time. Just to know that it is a concern, and it may be good to incorporate an inert gas into the bottling tank or the holding tank. That way, as we proceed through the bottling process, we're going to have that inert gas blanketing that wine so that oxygen is not going to dissolve into that wine to a greater extent in the latter stages of bottling. We already talked about recommended DO levels at the holding tank. To the bottled wine, we'd like to keep it below 1 parts per million. Some would say lower than 1, and I say that's a great feat to try to perform. So, usually whites and rosés, we like to be even lower because they don't have as much phenolic compounds or tannins to react with that oxygen. 2 of the 5 wines that were below 0.5 at the holding tank that we observed in the low area were within that suggested 1.0 parts per million DO to the bottle wine. So that's good. The other 3 were slightly above the suggested 1.0 DO in the bottled wine, but I think these could be worked out with proper SO2 management. The mid-range level that we saw at the holding tank observed DO increase to the bottle wine of about 1.7 parts per million on average, where the high DO levels at the holding tank saw an increase of DO to the bottled wine to about 3.1. So this is unacceptable here and well above the suggested limits. So really we need to, especially for this mid-range that we can work with and to get these lower on the high range, wine temperature becomes a concern. Anytime we have bottling stops, that's a time where we can have excess aeration from entering the wine. Filling the filling tank, have an inert gas on the filling tank. That can be critical, even if it's a gravity filled operation. That is critical, and bottle evacuation. So this is just a graph on the DO of the 14 wines that came in to show where they were at. So some below, some in the mid-range that I think are workable, but higher than desired, and those that are kind of unacceptable. What about bottle evacuation? And try to keep this moving here. So looking at bottle evacuation and its effect on DO, we did see a real pattern on that. So a bottle evacuation somewhere in the range of 2 to 3 volumes of that empty bottle prior to filling or with vacuum is critical in reducing our DO levels. And this did test true for both automated and gravity-filled operations. Even though gravity-filled operations without bottle evacuation led to undesirable results, and that was six wines, 2 of the gravity-filled operations that did practice bottle evacuation with an inert gas were near the suggested 1.0 kind of target level DO of the bottled wine. And that's good to know, because we have a number of wineries, and I know throughout the eastern section and Midwest that's the case, that do have gravity-filled operations. So I think you can achieve these numbers with the proper use of inert gas too, and handling in the cellar. This just looks at bottling evacuation based on whether it's automated filler or gravity filler, and we can really see the positive effects in the blue of when we had bottle evacuation with of oxygen with an inert gas or vacuum in general, compared to an automated filler that did not offer that. Same goes true for the gravity filler. So we saw an increase in oxygen when the bottles were not evacuated for the oxygen content. Looking at Headspace oxygen, and Headspace really is, as we know, is just simply the space of air between the closure and the wine. We did see a lot of variability, and it ranged here from 0.6 to 4.9, so quite a bit of variability. The suggested guideline that we see for Headspace oxygen is less than 2 parts per million to reduce oxidation and preserve sensory properties in the bottled product. Overall, we really saw 57% of the wines we evaluated were over this limit. 6 wines were well over the suggested limit, 6 were below. And then it's interesting that 3 of the wines that were below were from gravity-filled operations in the Headspace. So that's of interest there. This just shows the average Headspace concentration in the wines that we bottled. So again, 2 is our target level, below 2 actually. And we had a number that achieved that, but we had some that were much higher than that too. Headspace levels are dependent on fill volumes, obviously, also inert gas sparging, or vacuum at corking. It's important to know that screw cap closures actually can contain 3 times the volume of headspace. So it makes it more important to really take care of the headspace in screw cap operations, that we have ability to scrub more oxygen in there that can have a significant effect. And we can see the effect that headspace evacuation can have, taking it from 2.4 down to 1.3 or 3.9 down to 1.2 respectively. This just shows headspace evacuation when we look compared to bottled DO. The same thing here, similar trend to bottled DO, where if we have wines without headspace evacuation, or with it, much lower on oxygen content in the headspace than those that did not achieve headspace evacuation right here. When we look at headspace oxygen evacuation in comparison to total oxygen over time, the literature has shown that we should be less than 67% of the total oxygen content for acceptability. So we had 3 wines that were much higher than this, so 75 to 80%, which is unacceptable. 2 were gravity filled with cylindrical closures, and 1 was automated with screw cap closures. And each of these did not have headspace evacuation. Okay, I'm just trying to make sure I can get this in here. In contrast, the lowest headspace percentage at 27% came from gravity filled with no headspace evacuation. However, this is deceiving because it had such a high DO. The DO in this wine was 3.9 parts per million, and it kind of skewed this headspace percentage to 27. But the next lowest from 2 wines for headspace, low headspace percentage, was from automated lines which used evacuation techniques. This is just the percentage of headspace oxygen in the total oxygen content. So really we should be much below 50, but we had a little bit higher than desired headspace oxygen and much higher over this recommended to be below 67%. Total package oxygen is just simply the sum of DO and headspace oxygen. And there's some literature would state we should be below 3 parts per million total package oxygen. Ideally, I think it would be recommended below 2, and 1 for if we're using low sulfite wine, which I really hate to mention because I think sulfite management is one of our most important tools that we need to be where we should be according to wine pH and molecular SO2, as well as the amount of oxygen that we're picking up in our bottling line to account for. Although DO and headspace oxygen are important, TPO, is certainly equally important to monitor. So when we looked at after bottling at the different times and we evaluated total package oxygen decline at these different intervals, most TPO values, which is important to say, were consumed by day 63, with some that were high in TPO extending all the way to 126 days. But what this means is that it drastically reduced our free sulfur dioxide content. And so in pretty quick, really in 3 months, we were down to next to nothing on sulfur dioxide content. So that means that after 3 months, due to the extended time for both chemical oxidation and microbial growth potential is high to occur. So our shelf life stability is going to be severely shortened. The rate of free SO2 decline after bottling was correlated with initial TPO concentration. And the wines with the highest TPO levels observed the largest free SO2 drop within 4 months after bottling. And it was kind of a gradual decline that we've seen, but after 2 months, in many cases, we didn't see much at all left. But some other studies would show, beyond that, 4 to 12 months, saw another drop of 5 to 10 parts per million, and we did observe that as well. Now, some of that could be related to the oxygen transfer rate as well of the closure. Just quickly, this is from previous work that we did where we had 40 parts per million sulfur dioxide in at bottling. Looking at DO, we had a high case of DO. This is the one that tried to push after cold stability. So they were really high here on DO at 5.8. By really in 2 months, our sulfur dioxide level was below 10 parts per million, which is protecting that wine from any oxidation. So really of concern, as well as Headspace had a corresponding drop too, where at bottling we were 2.0 on average, and at 62 days we were down to 0.8 parts per million. So really of concern. So getting to some take-home points, it's really important to monitor and maintain SO2 levels in white wines to 0.8 parts per million molecular, and reds either 0.5 or 0.6 in reds based on pH. And it's important, now that we know how much oxygen we can potentially pick up at bottling, account for that with additional amounts of SO2. So knowing that 4 milligrams of SO2 can react with 1 milligram per liter of oxygen. If we assume we're picking up 3 ppm during bottling, total package, we would need about 12 parts per million molecular sulfur dioxide just for the amount of oxygen we're picking up at the bottling line. So that's important to know. Now, if we're not going to age that wine any further, if it's a wine meant for early consumption, we might just need the amount of oxygen to be at that 0.8 parts per million molecular level, but also pick up for oxygen. May not need any more for aging. If we're going to age the wine further, like for instance, some German Rieslings, maybe we would need another 10 to 15 ppm just for aging purposes. Just like in the cellar, limit sources for oxygen pickup at bottling. So make sure that we're sparging the bottle prior to filling, evacuating the oxygen there. Wine transfer pumping, make sure that we're paying attention to manufacturer directions, and we have no loose fittings that oxygen can scrub in. We tighten our filter pads, and maybe more importantly, we pay attention to the DO going into the holding tank. So make sure that we have an inert gas on the holding tank, purge any headspace that might be present, as well as the transfer lines. I already mentioned the pumping and filtration to keep things in mind there to prevent oxygen. Blanket our filler bowls, whether it's most of the time on automated bottling lines, that's kind of automated in there, but even manual or gravity filled operations, we can put a port on there and incorporate a inert gas on that wine that's in that manual filler bowl. Try to find filler spouts that are low in turbulence as long as we can. And then we already talked about flushing with 2 to 3 volumes of nitrogen to the bottle to prevent excess oxygen, and also evacuate the headspace with an inert gas in the bottles is vitally important. And if we're doing screw cap operations, the dose of liquid nitrogen into the wine, which will volatilize off or gas off and drive oxygen out of that headspace is vitally important. We can also incorporate vacuum at corking to reduce oxygen absorption too. And lastly, and sorry to cover here this last bit quickly just to conserve time, I want to make sure that, we know that closures can make a difference. So there's a lot of research now on closures, and companies are doing a pretty good job of paying attention to their OTR or their oxygen rate of transmission through these closures. And so choose a closure according to the wine that you're bottling. So two major factors of oxygen pickup related to specific closure are really the closure recovery time from compression. So how long does it take once that cork gets inserted or that closure, how long does it take for that to compress back to provide a good seal on the bottle of the wall, the neck, where oxygen can scrub into the wine at that point. And then also over time, over aging, the rate of oxygen permeation over time, which can affect shelf life stability. Some of the work that's been done and good work, we see level for oxygen permeation is lowest for screw caps and technical corks, where it's noted to be intermediate for natural cork stoppers and highest for synthetic or plastic closures. And there should be noted that there are variation between grades of each closure, as Lopez has found in his work and great work that he had done there. So, it's a lot of information. I think oxygen management, not only in the cellar, but specifically at the bottling line, is a real important topic. It's an important topic to monitor and maintain and do our best that we can to keep excess oxygen from entraining into our wine through either Headspace or the DO of the wine. And if we keep them levels low and where they need to be, that's going to help us, enhance our wine quality and extend our shelf life stability. So with that, I'd like to thank or acknowledge some of the people that were a big part of this project. Dr. James Glander, who I studied under at Ohio State University, who came back and helped with this project. And then I had two laboratory technicians, Patrick Piarki and Dr. Lisa Robbins, who is Dr. Lisa Dunlap now. And then the Ohio Grape Industries Committee is our committee that helps fund our research and extension projects. So certainly a thanks to them and their help with these projects. So hopefully it wasn't too fast, but I know it was a lot of information, but I think important information. So with that, Andrea, I guess if we have time for any questions, that would be good and entertaining.
Thank you, Todd. That was a great presentation. Thank you very much for that. We do have a question already. Have you ever used the oxygen meter on a bottle of sparkling wine? Does it read properly from your opinion?
Yeah, that's a great question. And unfortunately, we have not looked at that yet. But yeah, it would be interesting to see how that would affect with the CO2 amount in there too. But we have not looked at that. But that would be a neat practice to entertain or look at. So I really don't have any information or data on that.
Okay. Best practice for purging oxygen from partially filled tank. Recommended flow rate of gas and entry point.
Well, typically, first, I guess, one thing I would state is that I don't think that although inert gas is great to utilize, it's not a be all end all. So if we're looking at an inert gas to really control the level of a tank all the time with headspace that may be half or 3/4 full, depending on the vessel size and shape, I think we're probably mistaken. So I think we need to limit headspace first. But I think there's different things that we can do, and putting the inert gas in at the bottom of the tank is probably the best way to go. I have seen some cases where people will use like a dry ice block. This is more during wine storage or the winemaking process and cellaring, and they're using that CO2 that comes off that solid carbon dioxide wine dry ice block to help fill the void of that headspace. So there are some calculations out there that I think you can utilize for the size or the amount of dry ice to use for that situation. But I'd have to look at typical flow rates for to fill. It depends on how much headspace we're talking to fill. But just recognizing that it's important that if we do have headspace, and that's where we could use a DO meter to monitor the oxygen in that headspace to make sure that we're basically as low as possible or next to nothing in that headspace, and that way we know that we have the right dosage rate in that headspace, and that there's not enough oxygen in there for either microbial instability or chemical oxidation.
We have another question. Thank you for the answer for that. How did ancient winemakers make good wine without the technologies of oxygen management?
That's a great question. Maybe they use gravity more. There is some benefit to gravity operations and, less wine movement. And I guess I wasn't around, or we weren't around to do sensory evaluation of those wines at that time and what was acceptable. So, I don't know that I can answer that question directly, but I would say that gravity operations tend to be better because we don't have as much turbulence in the wine. Most likely, we're not moving the wine as much. Sometimes I think we can move the wine too much in the cellar, but we really have to pay attention to it. What it's telling us, kind of like those that have middle-aged and high school-age children. We really need to pay attention to that wine and what it's telling us. So if we're noticing just all of a sudden just muted fruit, then there's probably a chemical reaction going on that may be oxidative and something we need to look at.
Thank you. I have time for one more question.
Sure.
Any question? If not, I'm gonna wrap it up. We ran a little bit over. Thank you.
I was trying to pay attention to the translator too, to go a little slower. So
I appreciate that. This has been a learning process for all of us with the translation. I hope it went well. I hope people were able to take advantage of that. To all that have attended, thank you. Thank you very much, Todd, for your presentation. That was a lot of very good information, a lot of very good data.
Well, thank you. Appreciate your efforts as well, and everybody that attended.
Thank you, Agustin, for your translation. And please, 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 everybody take 1 minute to fill out the survey that will pop up once I end this webinar. Thank you all for being here. Have a good day, and then we'll see you next time.
Thank you. Take care.
Bye-bye.
Bye-bye.